Welcome back to James's Physics 101. Today, we enter the most stable phase of a star's life, the main sequence. This is where stars spend 90% of their existence. Think of the main sequence as the adulthood of a star. In our previous lesson, we saw how stars are born in nebulae. Now we explore the incredible balance that keeps them shining for billions of years. By the end of this lesson, you will understand the physics of hydrostatic equilibrium, the mechanics of nuclear fusion, and why some stars live much longer than others. A star enters the main sequence once it begins fusing hydrogen into helium in its core. This fusion creates an outward pressure that finally halts the collapse of gravity. This is the defining characteristic of a main sequence star. When we plot stars by their temperature and luminosity, most fall along this diagonal band. From the cool, dim red dwarfs at the bottom right to the hot, brilliant blue giants at the top left, this is the cosmic family portrait. But how does a star stay so perfectly spherical and stable? The answer lies in a beautiful physical tug-of-war called hydrostatic equilibrium. It is a constant battle between two opposing forces. Gravity wants to crush the star inward, while the intense heat from nuclear fusion pushes outward. As long as these forces are equal, the star remains stable. If fusion slows, gravity wins and the star shrinks. If fusion speeds up, the star expands. This thermal pressure is fueled by the most powerful engine in the universe, nuclear fusion. At temperatures exceeding 15 million degrees Celsius, hydrogen nuclei are moving so fast they overcome their natural repulsion. They fuse together to create helium. In the process, a tiny amount of mass is converted into a massive amount of energy, following Einstein's famous equation, E equals mc squared. This light eventually reaches us millions of years later. Surprisingly, the more massive a star is, the shorter its life. High-mass stars burn through their fuel at a furious rate to counter their immense gravity. Our Sun is a medium-mass star with a main sequence life of about 10 billion years. To recap, stars in the main sequence are powered by hydrogen fusion. They maintain stability through hydrostatic equilibrium. And remember, the bigger they are, the faster they burn out. In our next lesson, we will see what happens when the fuel runs out and stars transform into red giants and white dwarfs. Make sure to subscribe to James's Physics 101 to master the cosmos. I'm Carl Sagan, and I'll see you in the next lesson.